So mixed number division is going to be handled exactly the way that we have handled mixed number multiplication and fraction division kind of combined. And so the first thing is to recognize that we cannot multiply these things or divide these things as they are written. We need to convert them to improper fractions. So 2 2/3 is my other one. G method, multiply and add. G method, multiply and add. Rewriting these, 9 times 5 is 45, plus 5 is 50 over 9. Divided by 3 times 2 is 6, plus 2 is 8 over 3. Recognizing that I've got division, I'm going to whoop it. This helps remember that I flip the second number and change that to multiplication. So 50 over 9 times 3 over 8. And at this point, I could cross cancel like crazy. I'm honestly not going to worry about it because I'm going to get Wolfram to simplify the fraction at the end for me. But if you're, I'll put the or here for people that do want to see the cross cancel. We'll do that in just a moment. So 50 times 3 is 150. 9 times 8 is 72. If I'm trying to figure out how to resolve 150 over 72, Wolfram will be a great tool. Gives me the exact result of 25 over 12. And so now I have 25 over 12. I could say, okay, how many times does 12 go into 25? 2. That makes 24. I have a remainder of 1 over 12. Now on the right, if I was to do this using cross-canceling, I would see that those are both divisible by 2. That makes 25. That makes 4. I would see that both of these are divisible by 3. That makes a 3. That makes a 1. And I would get 25 times 1 is 25, and 3 times 4 is 12, which matches what I got on the left. I would still need to take 25 over 12 and convert it to a mixed number. 12 goes into 25 twice, making 24, with 1 left over. Okay. Four and 3/4 divided by 5 over 6. So again, important to recognize that what we need to do is do the G method here. To multiply there, add there. The other one is already a fraction, so we don't need to worry about it. 4 times 4 is 16, plus 3 is 19 over 4, divided by 5 over 6. So I see division, I need to whoop it. It helps me remember to flip over the second number, not the first. Or take the reciprocal of the second number, not the first. A fancy way of saying it. Now we have a multiplication problem, and it looks like we could do some cross-canceling, so I will rewrite it over here to do that as well. So if I do this, 19 times 6 is 114. 4 times 5 is 20. I will go ahead and use Wolfram to simplify that for me. 114 over 20. Remember to always check your input. Gives me 57 over 10. Now converting that to a mixed number, 10 goes into 57 5 times with 7 left over, giving me 5 and 7/10. If I was to put this problem straight into Wolfram, the way that we need to write it is 4 and 3/4. And all that has to be in parentheses. This is kind of tricky. So because we need that whole thing to end up in the numerator of a fraction, then divided by in parentheses here 5 over 6. We get 57 over 10, or 5 and 7/10, just as we got. But recognize when you're doing division in Wolfram, you want this stuff to stay together in the numerator. You want this stuff to stay together in the denominator. And so putting parentheses around what you need locked together is going to be an important step if you choose to use Wolfram to help you with fraction division. So going to the right where we could have used cross canceling. 4 and 6 are both divisible by 2. 19 times 3 is 57. 5 times 2 is 10. We would have ended up with the exact same process for converting this back into a mixed number. 10 goes into 57 5 times with 7 left over. Okay, on to the next one. We have 2 and 1/2 divided by 1 and 3/4. I'm going to do this in Wolfram first, just to make sure I show that method. So 2 and 1/2. Remember, it's going to be important to put this in parentheses because we're putting this in the numerator of a fraction to represent division. 1 and 3/4. Oops, I accidentally typed 4/4. Remember, always check your input. That says 4/4 should say 3/4. I made a typo. So our result should be 1 and 3 over 7. But this is how I would put something like this into Wolfram to help me check my work or help me do things a little bit faster. Let's go ahead and do it by hand. So for both of these, we do have 2 mixed numbers. So we do need to do the G method for both. And so I get 2 times 2 is 4 plus 1 is 5 over 2. 4 times 1 is 4 plus 3 is 7 over 4. I see division, so I know I need to whoop it, which is going to give me 2 over 5 times 4 over 7. And it doesn't look like there would be any possible cross canceling to do here, so we're not going to have that other option over here in this space. 2 times 4 is 8. 5 times 7 is 35. Is that what I'm supposed to get here? That's not what I'm supposed to get. What mistake did Schlegel make? 2 times 2 is 4 plus 1 is 5 over 2. 4 times 1 is 4 plus 3 is 7. I accidentally turned over both fractions. Look at that. What a silly mistake to make. Okay, this is why we invented the whoop it, so we don't make that mistake. So 5 over 2 times 4 over 14. Now there would be some cross canceling that could be done. So 5 times 4 is going to be 20. 2 times 14 is going to be... My goodness, I keep making mistakes when I write this darn thing. Okay, one more time. Schlegel must be getting tired. So, Schlegel, pay attention. Flip that darn thing over 4 over 7. There we go. 5 times 4 is 20. 2 times 7 is 14. So then converting that, or simplifying that actually is, well, we could convert it or we could simplify it. Let's convert it first. 14 goes into 20 once with a remainder of 6 out of 14. We can see that 6 out of 14, both of those numbers are divisible by 2. 6 divided by 2 is 3. 14 divided by 2 is 7. So that's going to be equivalent to 1 and 3 over 7. Is that what we got in Wolfram? It is. Over here on the right, when we get to the place where we're doing the multiplication, 5 over 2 times 4 over 7. If you're a person that loves cross canceling, you would see the 2 and the 4 cancel. That makes a 1, that makes a 2. That takes us straight to the answer of 10 over 7. 10 over 7 can then be simplified. 7 goes into 10 one time with a remainder of 3 over 7. Alrighty, that's going to be it for this one. I hope this has been helpful.